All right, hello everyone. My name is Aaron Standard, and today we are going to be touching on a subject that I've had a lot of questions about, which is how do you properly run Akka.Cluster inside of Kubernetes? We use Kubernetes for running SDK bin, and we use Akka.Cluster inside of that. And we've helped customers build, including like 1,400 node Akka.NET clusters on top of Kubernetes before. So we have quite a bit of experience doing it. And this video is really all about trying to culminate a lot of the lessons learned the hard way and a lot of the various issues we've helped customers solve all into one discrete video aimed mostly at production users. Now, if you're doing research on Akka.NET, you'll still get a lot of value out of attending this, but this isn't going to be a hold your hand step-by-step tutorial. We'll probably do one of those in the future, but this is really more about what are the pitfalls and sharp edges and best practices for working with Akka.NET in Kubernetes, and how is this going to impact the way you deploy your software. So the first place we're really going to begin today is actually our code sample. This is DrawTogether.net, which we featured in a bunch of other videos. I'll go ahead and link to the one on doing real-time streaming with Blazor and Akka.NET here. We've used this video in quite a few demos. We have, if you go to the actual repository, this Kubernetes folder right here, we have a couple of things going on. First, we're using Customize to go ahead and allow us to do things like automatically version bump our deployments when there's a new version of the application available. We're also using like Nginx ingress to go ahead and actually route traffic to the 3 instances of our application. We're deploying a SQL Server instance with a persistent volume. This is all designed for like local Kubernetes on your computer. We're not really doing this for like deploying to your Azure Kubernetes service or something like that. That configuration would look a bit different, but for being able to get some experience playing around with Akka.NET and Kubernetes, this application is fully featured. We also are going to flip between doing a deployment using StatefulSets and one using a normal deployment / ReplicaSet as well. There's some trade-offs we'll discuss later. That is all baked into it right here. If you scroll down, it'll go ahead and recommend accessing it via browser at this address right here, drawtogether.localdev.me. In fact, let's go there real quick. This is the application that we're demoing. We're running in anonymous mode, so you don't need to register an account. And if I go up and fire up a paint session, this should start drawing. Yeah, there we go. Took a second because I think it had to initialize some SQL tables at first, but that's all working. That's good. And if I go and copy this URL, open an incognito window. I'm not using HTTPS to secure the site. And let me go ahead and just get both of these running side by side here. You can go ahead and see one user drawing gets rendered on both screens. That's the whole reason for this application's existence. It's basically multiplayer Microsoft Paint. This is a great use case for Akka.NET, and we're going to use this as part of our study for working with Kubernetes. So why Akka.NET and Kubernetes? Kubernetes gets an unfair amount of hate in the .NET community, in my opinion. People treat it like it's this horribly complex piece of machinery. In my opinion, it's actually quite a bit easier to work with than trying to orchestrate all this yourself using a bunch of kludged together, ARM or bicep templates on Azure. But that being said, why is Akka.NET a good pair with Kubernetes? Why are they a good match for each other? Well, the first thing I'd mention is that Kubernetes has a concept known as a stateful set, which is basically a way of describing an application that is stateful. So rather than being your typical stateless CRUD app, where it's basically just a web API in front of a database, you actually can have applications like Akka.NET that have built-in state inside their application memory, which is where the source of truth lives. Stateful sets do a couple of useful things that reason about that very well. For instance, they make sure that every node in the stateful set has a stable, reusable identity. That's really useful for things like partitioning based off of a node's domain name or whatever. They also make sure that when you do a update to a stateful set, it's going to replace the nodes one at a time, which is, again, also useful for stateful nodes. You don't want to do something destructive like a VIP swap, a virtual IP swap, where you have a brand new environment and then you swap it into production to replace the old environment. That doesn't work very well when you have state inside your application. That's going to create a split brain when that occurs. So stateful sets are one thing that really kind of favor the use of Akka.NET inside of Kubernetes. I would argue, though, probably the biggest reason for working with Kubernetes is that it greatly simplifies the networking requirements for something like Akka.NET. Akka.NET and other peer-to-peer application frameworks like Microsoft Orleans are building mesh networks. Every node needs to be able to communicate with every other node inside the network. That's the fundamental essence of the sort of peer-to-peer networking model that these types of applications require. Kubernetes services provide a really simple, low-effort way of being able to facilitate that and make that addressable across multiple machines. The alternative, doing things directly on top of Azure App Services or whatever, usually involves having to jigger firewall rules and private networks and security groups, and there's a lot of legwork that goes into making that all secure, whereas Kubernetes provides a fairly streamlined experience by contrast. Next, customizable health checks for graceful transitions. One of the other things I've really grown to appreciate about Kubernetes over the years is that if you're building a stateful application, one of the things you don't want to do is absolutely rug pull your production application and try to swap everything out all at once, because there can still be important activity that is happening in flight in that system right now that you want to have recorded in your system by the nodes that are being shut down for something like a software update. You want to give those nodes an opportunity to gracefully transition, to hand over their work to somebody else, to finish saving the work that they were performing to a database or some other durable object store. Or you might want to be able to make sure that they basically just get enough time they need to properly clean themselves up before they shut down. Things like the termination grace period setting for Kubernetes, or the other ability to invoke things like custom functions as a node is exiting, really help complement a tool like Akka.net pretty well in the grand scheme of things. And then finally, I would say this isn't unique to Kubernetes, but it's something that Kubernetes makes very easy to do. It's very easy to orchestrate a zero downtime rolling upgrade in Kubernetes. Essentially, you can just introduce a new Docker container tag that has your application running in it, tell the StatefulSet or the deployment to use it, and you can configure your deployment strategy to kind of gracefully begin introducing that. And as long as those nodes pass their liveness and readiness checks, the deployment will continue. And if they don't, the deployment will fail, and you can roll it back if you're doing a deployment, or if you're doing a stateful set, the deployment will simply stop from that standpoint. So this makes it very kind of easy to go ahead and orchestrate the types of upgrades that Akka.net needs, whereas other platforms and services might be a little bit more ham-fisted about how they do deployments. They might have a one-size-fits-all model where it's going to try to roll out an update to every single node all at the same time, which is going to be a little hard for something like a stateful application to support well. So these are some of the key reasons why Akka.net and Kubernetes work well together. There's probably others that I'm overlooking, but these are the big ones that I tend to think about when I'm doing my day-to-day work with Akka.net and Kubernetes. Now, if we take a look at the sort of networking picture for Kubernetes and Akka.net, what does that tend to look like? This is actually not all that far removed from what we're doing inside SDK bin in production. We expose a public web API on each of our pods, and that is basically going to be our public way of communicating with the outside world. So that's where we're going to handle HTTP requests. Maybe we'll have some gRPC functionality or WebSockets that we expose. In the case of DrawTogether, we're doing both web requests and WebSockets using Blazor server. But we'll go ahead and expose that to the outside world. And that's all going to be exposed either via load balancer, or in our case, we're actually using Kubernetes ingress. Ingress versus load balancers has Zippo to do with Akka.net. That's not a thing Akka.net cares about at all. What we care about are the headless services that we're going to use internally. These headless services are what create the address space that makes it possible for these pods to communicate with each other seamlessly across multiple hardware instances. So these are the real kind of sticking points that make it easy for us to build our mesh network internally. We're going to rely on this headless service to kind of create the addressing space we can use to contact nodes across multiple physical Kubernetes nodes inside our cluster. Now, the first decision you're going to have to make when it comes to working with Akka.net and Kubernetes is which deployment type are you going to go with? You have two big ones. You have the StatefulSet, which we've talked about already, and the deployment. And there are some trade-offs at work here. The biggest trade-offs are going to be how upgrades actually happen, and we'll get to that at the very end. But let's start with the simpler stuff first. The first big advantage of StatefulSets is their DNS schemes are stable. You're going to be able to reuse that pod's identity over and over again between deployments. And this means that tools like seed nodes for forming an Akka.net cluster are actually viable with a StatefulSet. You don't need to use Akka.Management if you don't want to. You could simply use a seed node configuration, and that will just work out of the box using StatefulSets. And that's why if you were, an Akka.NET user 6, 7, or 8 years ago, or maybe even more recently than that, you probably saw us recommending StatefulSets all the time because they're what makes seed node Akka.cluster formation possible. You don't need to use that anymore now that Akka.Management's a thing. Akka.Management can work just fine with Kubernetes deployments. So that sort of seed node configuration was necessary a long time ago. These days, it's less important. Akka.Management can kind of automate away the need for that, which is really nice. I would argue the biggest problems that StatefulSets have, and the reason why I probably will favor deployments over StatefulSets these days, the biggest problem that StatefulSets have is twofold. For starters, the way they introduce updates to your cluster is actually going to create a lot more rebalancing than a deployment is going to. And we've got some slides that illustrate this specifically, but we'll talk about that in just a moment. So this is going to be, ironically enough, the StatefulSet is going to exert a lot more pressure on Akka.cluster sharding in particular. That's what we're referring to when we talk about rebalancing. We're talking about Akka.cluster sharding and how frequently shards have to get moved. StatefulSets are going to exert more pressure on the sharding system, and essentially every pod is going to have to get rebalanced twice. That stinks. That's not great. We can avoid that by customizing the way deployments work with our Akka.NET application. And the personal reason why I moved away from StatefulSets on SDKbin is we had to manually intervene and fix our StatefulSets when deployments failed. Now, in our case, it typically was never an Akka.NET issue that caused this. It was almost always an issue with our init container that we use to apply Entity Framework Core migrations. We've gotten rid of that too, by the way. We don't use we don't use init containers to do migrations anymore. We use our build pipeline to do that now. But the way things were originally architected on SDKbin 4 or 5 years ago, that was how it was done. This is something that is still an issue with StatefulSets. If something goes wrong, let's say a pod fails its liveness check, that's just going to halt the update, and you're going to have to hop in and manually intervene. You can't very easily do an automated rollback with a StatefulSet. That'll usually require a bit more instrumentation. Whereas with a deployment that fails, you can do a rollback quite easily. That's something that deployments do very well out of the box. Now, in terms of the weaknesses of deployments when it comes to Akka.NET, they have two, and they're fairly small in my opinion. One is that they all require Akka.Management in order to work. You're not going to be able to get away with seed nodes because domain names are dynamic in the system. And that's just a price of admission for working with deployments. Most of the Akka.NET templates and applications that we see out there already use Akka.Management anyway, so I consider this to be kind of a nothing burger. The other issue that deployments are going to have, and there's one more that's not listed on the slide, is that in order to do deployments well, you're going to need to temporarily increase the number of pods during your deployment using a surge, which means that you're going to go from maybe having a stable working set of, let's say, 3 nodes in your cluster. You're going to have at least 4 running while you're doing your deployments initially. And that's just kind of the way it's going to go. If your system is running in such a threadbare fashion that you can't run an additional pod, you've got problems a lot bigger than trying to choose between StatefulSet and deployments. So as long as you're not, running this on a shoestring Kubernetes cluster, you should be fine. 1 extra pod should not kill you. The other issue that I would mention here that is not on the slide is that if you're using deployments to go and run an Akka.NET cluster, you actually can't use DNS. You're going to want to use IP addressing instead for addressing each of your nodes individually. And the reason why is the relationship between a headless service and a pod is a lot different in a StatefulSet. With a StatefulSet, you can do DNS prefixing. With deployments, you don't really get as much flexibility there. Working with IP addresses ultimately becomes the simpler way of reasoning about it. And I'll bring up one other point. The other reason why using IP addresses might actually be helpful is we have a number of customers that use Carpenter for being able to shrink or basically not shrink, but being able to rehome pods to, let's say, things like spot instances on AWS. That is going to exert a ton of pressure on Kubernetes' internal DNS system because it's going to have to essentially repoint an old DNS record to a new IP address every single time you're moving pods around if you're using StatefulSets. If you're using IP addressing, you avoid that entire category or problem in its entirety. And so it might be better and more advantageous to use IP addressing from the get-go. That's what we're using on SDKBin, and I haven't run into a scenario where I've regretted doing that yet. So this is what a StatefulSet rolling update might look like. We're going to try to migrate all of these pods to the latest version of the application. So we have 3 pods running. What's going to end up happening when I update my StatefulSet to use a new Docker image container is that we're going to take one of the pods out of the cluster. So pod 2 is going to go down, and that's going to cause a rebalance when this happens. Pod 1 and pod 0 are going to receive all of the Akka.Cluster sharded entities that are on here, and they're going to get redistributed to these 2 pods when that happens. That's going to be what causes a little bit of the chaos when the system first starts. But then pod 2 is going to come back online, and then some of the shards that are allocated to pod 1 and pod 0 will start getting reallocated onto pod 2. So that's the 2 shuffles we're talking about. But then to make matters worse, pod 1 is going to go down, and that's going to cause a rebalancing between pod 2 and pod 0 to happen. And then finally, we're going to pull pod 0 out of the cluster and mark that pod as down. And after this is all said and done, we should have a successful update when this occurs. But we're moving shards around pretty frequently as part of this update here. And that's what's going to create a little bit of stress on Akka.net when you're doing this. The other approach using rolling updates is a little gentler on the cluster. We have the same number of pods, but what's going to happen here is we're going to configure it to surge, where it's going to bring in an additional brand new pod that is going to have the new version of the software running on it. And when that occurs, it's going to cause pods A, B, and C to maybe begin rehoming some shards onto pod D. But what we're actually going to see happen is that as soon as pod D comes online, pod A is going to begin exiting, and it's going to basically go through its termination process. And all of those shards that are on pod A will probably get rebalanced onto pod D if this process proceeds at a reasonably quick pace. Next, we're going to bring in pod E, and then we're going to begin removing pod B. And as the story goes, we're going to eventually replace everything. This is actually a lot gentler on your cluster because unless you have a very long time, let's say 30 seconds between, I don't know, pod D passing its readiness check and pod A beginning to get shut down, you're not going to have a bunch of duplicate rebalancing happening the same way you would with the StatefulSet deployments. So that's why using a deployment over a StatefulSet might actually be the better choice in the era of Akka.Management for Akka.net. Let's go ahead and cut here and take a look at an actual demo of this strategy in action. So this tool you're looking at here is K8s. I haven't updated it in a while. I guess I need to fix that. K8s is a great management tool for being able to work with Kubernetes clusters. And we're just connected to the Kubernetes cluster that's running locally using Docker for Windows on this machine. If I take a look at this particular container, we're running version 0.2.12. And if I take a look in the logs, you can see there's some activity here. This all looks well and good. So this is using the deployment system right now. And what I'm going to go ahead and do is I'm going to pull up DrawTogether.net's release notes file, and I've bumped that to 0.2.13. Okay, so that should trigger an update. And I will go ahead and call build.ps1. This will go ahead and bump the actual version number in the directory.build.props. And our deployment script, which I'll do down here, we'll set this to strategy. Deployments. This is going to automatically build a new Docker image if we don't have one for this version number already. And it will roll out a brand new Docker image that has our Entity Framework Core migrations on it and our Akka.net application as well. So let's go ahead and kick that off. And looks like it didn't find my Docker images. So it's going to begin building those, and it's going to use the deployment strategy. If you leave the strategy parameter off, this will deploy everything as a StatefulSet. And this should be sort of a single shot that gets everything done all in one go. So let me cut here and just kind of wait until it starts doing the deployment. Okay, so we have just now begun rolling everything out to the cluster, and get a load of this. We can see our surge beginning down here. So we can see some additional containers spinning up. That was our migration. This is our new pod coming in with the new version. And let's go ahead and take a look at the logs here. I was able to join the existing cluster. That's great. And then if we back out here, we're going to begin seeing some of these other nodes leave once the readiness check completely passes here, which it should. Oh, there we go. The readiness check passed. And now the other containers are terminating. And let me go ahead and pause this. We'll go ahead and let the process just completely finish here with all containers being cycled out. And we should see a healthy 3-node cluster once we're done. Okay, so it looks like we've got a 3-node cluster formed here. So let's go ahead and take a look at one of these containers. It's all running the right version of the software. You can see some member removed messages here. This is probably from the old nodes leaving. Let's go ahead and use the Petabridge Sidecar container, and let's see if I can exec into this. Let's see if I go click on that and I do shell. I can go do PBM cluster show, and I can see that we have a 3-node cluster here. And we're going to touch back on this in a little bit, but using the Petabridge.Command sidecar container, also a really good idea for working with Kubernetes. So that is how our little deployment rolled out inside an actual Kubernetes cluster, just like we showed on the diagram. All right, so I've just redeployed the application as a stateful set this time, which you can do by using the basic, well, if I just go Kubernetes deploy.ps1, that'll go ahead and roll everything out as a stateful set by default. And one important difference to take a look at, if we go and dive back into the logs, let's take a look here, is if you notice the domain names for Akka.net here, they look like this. We had IP addresses before, but now it's DrawTogether-0. That's the pod ID. .DrawTogether. That's the domain name we get from the headless service. We'll talk a little bit more about that once we look at the YAML. But long story short, this is how we know we're running inside of a stateful set. Okay, so that's all well and good. I'm going to put my version number back to 2.1.3, and we're going to deploy that real quickly. Let me go and run. Meant to run build.ps1 first to go and bump the version number inside the solution. Let's go and do that. There we go. And now if we do deploy.ps1, it's going to begin applying the existing image here. All right, there we go. And if we start taking a look at our images, you'll notice the first thing that's happening is DrawTogether 2 is getting terminated, and it will be rebooted with the new version, and then it'll work its way back to the other nodes that are here. And this is exactly what we illustrated on our chart earlier. Just wanted to go ahead and demonstrate this is actually the behavior that Kubernetes is going to use out of the box. So we don't need to watch the rest of this deployment. Let's go ahead and take a look at how you would actually go about configuring your Akka.net application to form a cluster inside of Kubernetes. Now, if you haven't watched our video on Akka.Management, I'd strongly encourage you to do that, because that's what we're going to use to go and form our Akka.net cluster in either case here. The basic gist of this is that we have an extension method that gets invoked from the minimal web API configure Akka. That's going to call all the wonderful Akka hosting methods under the covers. And we're going to essentially pull some configuration data in from Microsoft.extensions.configuration to get a couple of different things ready inside our application. The most important method we want to take a look at right now is this configure network method. This is a custom method I wrote that is going to specify how we are going to configure Akka.Remote, Akka.Cluster, and Akka.Management. We'll talk about the TLS settings a little bit later. Here's the really big one. If Akka.Management is enabled, and you can take a look at our exact, we can go ahead and look at this. This is our exact sort of settings class. This is using a lot of the built-in stuff from Akka hosting. And this is a custom Akka.Management object that I defined, where it's just a simple POCO class here. But basically, we have a toggle to enable it or disable it. And then we have the ability to set the host name for Akka.Management.http right here. And that is somewhat important. If we go to our configuration and Akka.Management is enabled, we are going to disable our seed nodes, regardless of what's in configuration. If seed nodes are specified, Akka.Cluster is going to automatically try to join those. We want to turn that off so we can let Akka.Management do its thing. Down here, we are going to configure Akka.Management to use the host name that is specified in this configuration file. Now, I'm going to make an important note here. When working inside of Kubernetes, you should leave this setting blank. We're going to see that when we go to our YAML file. And the reason why is that the way all of the pod discovery stuff works inside Kubernetes is all based on IP addresses. So trying to use DNS or host names here is going to create more problems than it solves. Different environments might have different requirements, but within Kubernetes, it's a lot easier to use IP addresses. So this setting is effectively left blank in the rest of our environment, in the actual Kubernetes environment. Now down here, we're going to go ahead and just bind to listening on 000. This is basically configuring the HTTP server that Akka.Management uses to figure out which nodes we found during service discovery are actually available and who's already in a cluster and who isn't. That's what this is all for. And then we populate cluster bootstrap down here. This is all pretty much a recap of what's in the Akka.Management videos. You should watch that. But the really interesting thing down here is the Kubernetes discovery. If we enable discovery method.Kubernetes, we just call builder.withKubernetes discovery, and we don't particularly need to specify anything more detailed than that. Now, you can pass in a couple of custom options here if you want to. The only really important things to get right is when you set cluster bootstrap, you want to make sure that your port name is going to basically match what the port name is of the service that we're going to use to expose Akka.Management. So let's take a look at our actual YAML file real quickly. I'm going to grab, let's see, if you go to the DrawTogether.net repository and you go to Kubernetes, you're going to want to take a look at the service. The service is going to expose 3 ports. Management, this is the port that we're talking about right now. We're going to then expose Akka.Remote. This is the port that the mesh network needs in order to form everything together. And then finally, we are going to also specify the HTTP port. This is what our ingress router is going to use for routing traffic to this application. So all 3 of these ports have a job. Only the port 8080 port is going to get exposed publicly to end users. The rest of these are all for internal use. Now, a couple of other important details about this headless service that our application is going to use. You want to specify cluster IP equals none. That is what makes this service headless. You want to make sure that we do that just so you don't end up trying to expose any of this publicly anywhere. So you want to specify cluster IP as none. And then this setting right here, publishNotReadyAddresses. This is a pitfall that you want to avoid when working with Akka.net for one really important reason. The way the DNS system will typically work for something like StatefulSets is that you will not have the ability to propagate StatefulSet DNS entries until those pods have passed their readiness checks. Well, what do you think is going to happen to a pod that has, let me find the health check registration here. Here we go. Akka.Cluster readiness check. This is one of the brand new health checks we just introduced into the most recent versions of Akka hosting. We have a video on that as well. Well, if you have a health check like this that basically checks to see if you've joined a cluster, that health check can't pass until we've successfully contacted other nodes and joined them. Well, if we aren't publishing our addresses until we're ready, and we're not ready until we've joined a cluster, that means other nodes who are trying to form a cluster with us can't connect and reach us either. And this can basically create a little bit of a deadlock inside your Kubernetes environment where no one can connect to anybody else because the DNS entries aren't being propagated yet. By setting this value to publishNotReadyAddresses to true, this will essentially start publishing DNS entries the second the pod comes online. That is the ideal. That's what we want to do. We're going to go ahead and enable that. Next, if we take a look at our, I guess it doesn't matter if it's a stateful set or the actual deployment. Yeah, let's go ahead and take a look at the, stateful set down here. Okay. So this stateful set, it has a couple things going for it. First is the actual labels that we're going to use. App is DrawTogether, and then cluster is DrawTogether. Okay. How does Kubernetes.Discovery in Akka.net leverage this information? Let's take a closer look at that. So the label selector that Kubernetes Discovery is going to use defaults to this, app equals blank. And this blank value is going to default to, if I go back to DrawTogether real quick, let's see, DrawTogether, Akka configuration, it's going to be equal to whatever the service name is. This is going to be the key that we're going to use for both storing and retrieving service discovery values with Akka.Discovery. So we're going to end up with a label selector that looks like app equals, and then whatever this value is, and I believe we have it defaulting to DrawTogether. So app equals DrawTogether is the default label selector for the cluster bootstrap service. And as it so happens, if we take a look at the YAML, our app label up here is DrawTogether. So Kubernetes is going to basically publish inside the control plane the list of all pods in this namespace that have this app label on it. And Kubernetes.Discovery is going to go looking for those. One of the next things we need to do in order to make sure this works properly is to ensure that our pods have the appropriate permissions to essentially read the set of all available pods inside the current namespace. So one of the things you'll notice up here is that we're going to assign it the service account, DrawTogether. If we take a look in our configurations, if I go down here, we have here we go, set of RBAC permissions, a service account, and that service account is going to be scoped with the pod reader, and then I added a couple of other role bindings here that have nothing to do with Akka.Discovery and everything to do with basically being able to figure out if our entity framework core migration is completed. That's what the rest of this stuff does. But the big thing that we want access to is we want to go ahead and create a service account. We're going to call it DrawTogether, a role that gives us the ability to get, watch, and list pods. That's what we need for service discovery. And then we'll create a role binding down here to basically make sure that read pods role gets bound to our service account. Doing all of that will allow these pods to implicitly query the Kubernetes control plane, get the addresses back from all these pods, and form a cluster with them. So if we go take a look at some of the logs, some of these pods up here, you'll notice this type of information being returned. Return 0 seed nodes, then it returned 2 seed nodes. That's the Kubernetes control plane basically giving us data back that we're querying via Akka.Discovery.Kubernetes. And this will all just work behind the scenes. If you run the .NET Aspire configuration of DrawTogether.net, which all runs locally on your machine, that's going to use the Akka.Discovery.Azure engine instead, which relies on an Azure table storage instance being available. These are some of the various service discovery mechanisms that are built into Akka.net at play there. So that's going to be all that we need to kind of go ahead and get a cluster up and running using the Kubernetes discovery system. If we take a look at the environment variables that we specify on our actual service itself down here, this stuff is not radically all that different from what we've done in a number of other tutorials. We're going to specify the Akka.Remote port, the public host name. In the case of the StatefulSet, the host name is going to be podname.servicename like this. That's how we get those nice looking domain names we had earlier. If we do a deployment instead, which I think should be under, here we go. If we do a deployment instead of doing the host name like we did, we'll just pass in the pod's IP address here, which we extract from using one of these little metadata fields that we can get off of Kubernetes directly. We get the pod IP address, and that's going to end up being our host name instead. So this is all very straightforward from a configuration standpoint. Really, the learning curve here is learning how to the pairing of Kubernetes Discovery, Akka.Management, and the actual Kubernetes permission system all work together. This sample is batteries included, and that'll get you off the ground with it right away. So that's all you need for the initial cluster formation piece inside of Kubernetes. We've got a lot more stuff we need to cover still, but this is sort of the basics of forming a cluster and getting it up and running. Now, the next thing I wanted to touch on for Kubernetes is talking a bit about basically liveness and readiness probes and also the graceful termination period. What is it that we want to do, particularly using the brand new HealthChecks system we've just introduced into Akka hosting? How can we leverage that for maximum effectiveness inside Kubernetes? Well, if you've done a bit of work with Kubernetes already, you're probably very familiar with this concept of liveness versus readiness probes. But if you're not, this will be very useful for you. So the liveness probe answers the question, is this process alive? If a liveness probe fails, that pod is going to get rebooted instantly, usually. Liveness probes, generally, as soon as the system starts, these should always return true. This should only really return false if, for instance, your pod got kicked out of the Akka.net cluster and the actor system is in the process of shutting down. You might want to go ahead and signal via a liveness probe the actor system's dead. That would be a useful data signal there. Readiness probes are a little bit different in that they're designed to kind of communicate to Kubernetes, is this process ready to accept traffic? Typically, it's going to determine whether or not traffic is routed to you from tools like a load balancer or an ingress. So this should include things like whether or not you have access to all the resources you need to do your job. For instance, if you have to apply migrations to a database, you should not return ready until you know those have been applied already. If you end up failing your readiness check, sometimes that pod will get pulled out of the load balancer. I think that depends a little bit on how frequently the readiness check gets invoked, how many times it's failed, etc. That's all fairly configurable. But these are the two different health check flavors we want to work with. The brand new Akka.Hosting health checks we just introduced make it very easy to facilitate these. So let's take a look at the source code for the application and then at the actual Kubernetes YAML itself and see how we can take advantage of that. Now, inside our Akka.NET configuration, we're registering 4 health checks. We have the Akka.Cluster readiness check, an actor system liveness check, and then we're using Akka.Persistence SQL for storing all of the actual drawing data. We're going to use the brand new health checks that we've just added to Akka.Persistence. We haven't made a video about that yet, but we will soon. We're going to go ahead and check to make sure the journal and the snapshot store have not reported any significant failures lately. That's what these health checks do. These are really readiness checks. Well, that is all well and good to kind of get these health checks integrated into the Microsoft.extensions.healthchecks plumbing, but we need to expose these as HTTP routes in order for Kubernetes to actually leverage them. And I think if we take a look at program.cs, I have a little extension method I have defined for that. I wonder if this is the method. Yes, here we go. This is the method that I defined for mapping our health check endpoints. So we have a couple of different flavors here. First, we have the healthz endpoint, which will return all health checks without any filtering. This is mostly for diagnostic purposes. We have a little function down here, this write health check response. This is going to essentially pretty print all of the JSON output for a health check. In fact, if I go to one of our, pages here, and let's get out of F11, and I go to, let's say, healthz, you can go ahead and see sort of what the output looks like here. I also have things like some Entity Framework Core health checks attached to this as well. That's pretty useful. If we go back to the application, though, we have 3 endpoints. We have healthz/live, which uses a predicate that says, does this tag contain liveness? Okay, that's useful. And then we also have another predicate down here. This is looking for Akka.Persistence. That really should be ready is the right word. That's what we want to go look for, ready. And maybe this should just contain live. That's probably a better way of phrasing it. And if we take a look at these endpoints, we're going to notice a little bit of filtering. By the way, these are filtering based off the tags that are defined right here. So liveness, ready, and so forth. So I go to healthz/ready. The only health checks we'll have in here are Akka.Persistence health checks. And if I go to live, the only health check that we have here is basically looks like we have a default liveness health check for the application being up and running. And then maybe if I go to healthz again, there should be one for, I guess that's actually the actor system health check. Oh no, that's down here, and that's only tagged with Akka. Well, I'm going to need to go and fix that and add a tag to it as well, which is something that Akka hosting will let me do. That's the basic gist of the health check configuration from the C# side. From the actual YAML side, it's very easy to go and configure these. If we scroll down, you'll notice we have some liveness probes and some readiness probes. These are going to try to hit the following endpoints inside the container. So we're going to have the healthz/live probe hit every, I think, 20 seconds roughly, and we're going to tolerate up to 3 failures before we decide that this probe is in fact dead and needs to be removed. That's pretty generous. We could probably reduce this if we wanted to, but you also don't necessarily want to have your health checks getting hit all the time because they might do things like open database connections. The readiness health checks are going to run more regularly. They're going to run every 10 seconds, and they're going to hit this healthz endpoint right here. So that traffic will all be directed to the probe's HTTP endpoints here. So that's a really simple way to get Akka.NET health checks integrated directly into Kubernetes. The big thing you want to make sure you get right is these predicate functions and then the tags that you specify on these little checks here. These are the main things that we want to try to make sure we get right as part of making our health check circuitry fully integrated between ASP.NET Core, Entity Framework, Akka.NET, and Kubernetes itself. Now, the next thing I wanted to touch on is being able to manipulate and work with your Akka.NET cluster inside of Kubernetes. Now, obviously, one of the best tools that we have for doing this is Petabridge.Command, which is, our free command line tool for being able to manage and work with Akka.NET clusters. We have a bunch of videos on that on the channel as well, I believe. One of the things that we shipped recently over the past year or so is a Petabridge.Command pre-built Docker Sidecar container that we expose. This will allow you to take the Petabridge.Command client and attach it as a very small, lightweight binary inside the pods where you're running Akka.Cluster. You saw me invoke this a little bit earlier. The way you can go and configure this inside your application is that as long as your Akka.Cluster application has Petabridge.Command enabled, which I believe we do. Yeah, here we go. We go and we configure it in this little lambda right here for like optional values, and we register the cluster commands and the cluster sharding commands here. This will bind Petabridge.Command to its default port, which I believe is 9100, actually 9110. Yeah, 9110 is the default. So this will bind it to, that bit of C# code will bind a private port that is not shared outside of your container for Petabridge.Command. What you can do in order to get a sidecar up and running is simply go to your deployment or your StatefulSet, and you're going to attach an additional container right here, PBM sidecar, Petabridge/PBM latest. This is an image that we published directly to Docker Hub. We probably need to do an update of this at some point soon here, but you can go ahead and pin this to a specific version of the PBM client if you want to, or you can pin it to the latest version. Doesn't really matter. But what this will do is give you a little sidecar container you can use down here to shell into. If I go and actually we back out, go here, and then I think I need to, in order to attach, I need to press S. There we go. I can do PBM cluster show. That will allow me to go ahead and take a look at the current state of the cluster. I could do cluster sharding, regions. I could do region stats, I think it's drawing session. And this will give me a printout of like where all of my shards are inside the cluster. So this is really useful for diagnostics if you have the ability to exec into your Kubernetes cluster while running Petabridge.Command as a sidecar. For local development or at least validation in a non-production environment, this is a very useful tool for being able to both troubleshoot and manage your Akka.NET cluster inside Kubernetes if you want to. So definitely check out the sidecar container. We're going to have links in the description to all this stuff. So check that out. Now I'm going to make this part quick. One of the other things that would be a really good idea to have, this is running inside of our production Kubernetes cluster for SDK bin right now. This is the Phobos metrics plus dashboard, kind of reporting on how busy looks like this is taking a look at the sharding system right now. If I want to take a look at one of our user-defined actors, let's take a look at the package download counters actor. I can see that we've got 6 actors active right now. We've only processed about 6.2 messages per second over the past however long this time window is, last 30 minutes. So not a super busy system in particular here. Looks like we've just had a little recent burst of traffic over the past few minutes or so here. But this plus our Akka.Cluster dashboard, which will kind of illustrate how well all of our various services are performing. Let's take a look at let's look at the QA. Look at the production environment. Why not? We can kind of take a look at get an overall lay of the land of what our production environment looks like here. Phobos is one of the commercial products that we sell to help support our development on the Akka.NET project. I recommend using this for monitoring not just your Akka.NET applications in Kubernetes, but really monitoring them in any environment that they're in as well. So just wanted to touch on that real quickly. The Petabridge.Command tooling is all free that we showed a second ago, but it is a little invasive, and you might not be given access to execute commands against containers in your live environment. If so, this is a pretty good way of being able to safely exfiltrate telemetry data into a system like Datadog or Prometheus or whatever, so you can kind of help understand how well Akka.Cluster is performing that way as well. Now, one of the other subjects I wanted to touch on a little bit, this typically does not matter for most Akka.NET deployments, but for some environments where maybe you're operating under regulatory requirements or maybe you have a zero trust security posture, one of the things you might want to do is enable Akka.Remote to run with transport layer security enabled. Akka.Remote uses, in fact, we're going to do a video on this very soon, so make sure you're subscribed. we're going to do a video all about how we actually use mutual TLS, where both nodes in the cluster that are joining each other have to validate each other's certificates in order for a cluster to form when you're running with TLS enabled. Well, in order to use TLS inside Kubernetes, you're going to want to do the following things. The first is if we take a look at the actual program and we look at where we are configuring Akka.Remote, if we enable TLS settings, we are going to want to configure Akka.Remote to use the appropriate certificate. So we're going to go ahead and basically grab the certificate from our config, and we're going to stick this into Akka.Remote options.ssl options. This is going to be the certificate that we're going to use. And in this case, I'm disabling chain, basically validation of the signing authorities for the certificate, which you should never do in production. I'm doing this because this sample ships with a self-signed certificate, which means that it would not, by definition, pass this type of validation. Stay tuned for our video all about Akka.NET network security. That is the next video I'm working on. So that should be coming out very soon. We're going to get into a lot more detail about how this works, but let me show you how to configure it in Kubernetes. This is all the Akka.Remote piece, and it's very simple. In Kubernetes, we have in our little PowerShell script that we use for deploying the cluster, we are going to go and create a TLS certificate using just a self-signed certificate that we think we actually have it stored. Let me look here. Certs, yeah, here we go. We have a self-signed certificate committed directly into the repository. This is what we're going to use to facilitate transport layer security inside our Kubernetes cluster. And what's going to ultimately end up happening is this piece of code right here is going to generate a secret inside the namespace where DrawTogether runs that has this certificate file embedded inside of it. That's what we're going to do there. If we take a look at our deployment and I scroll down a little bit, we are going to mount our secret, our TLS certs secret as a volume, and we are going to basically extract that certificate out of it, stick it in as a file. And the actual certificate name is going to be the /certs Akka.node.pfx. That's all based on the actual directory these secrets being created from on the host machine originally when we define it. And then we're going to pass in our certificate password. You can incorporate this as a Kubernetes secret also if you wanted to. And then we're going to just simply suppress TLS certificate validation down here. In fact, this probably should be mapped as a secret. That's something we should really improve in this code sample. But this is all the information you need in order to get TLS up and running inside Akka.Remote. And we can tell that TLS is working based off of the domain names here. You will notice this Akka.ssl.tcp. This is Akka.Remote's way of telling you that you're running with the .NET transport, which is the default transport in Akka.NET 1.5. It's telling you that you're running this with basically transport layer security enabled when you see that SSL appear on here. And if I go back to our little PowerPoint, you'll notice that's at the very end down here. If you misconfigure your certificate or if there's some other problem with it, like maybe it doesn't pass the root validation check, you'll see a bunch of angry looking startup errors occur if your certificate is bad. If someone else's certificate is bad, you'll see errors occur during the actual handshake process. We will cover all of this in our next video, I promise. Finally, I just wanted to share a couple of parting thoughts about working with Akka.NET and Kubernetes. One other piece of infrastructure that Kubernetes exposes here that I always take advantage of is this, terminationGracePeriodSeconds. This is the delta between when a pod is told to shut down and how long Kubernetes will actually give it before it forcefully shuts the containers down inside of it. So I'm requesting 35 seconds here, which should be ample time to migrate all of my shards, all my cluster singletons, and finish persisting any data that I'm currently processing. I always try to take advantage of this when I'm working with Kubernetes because I know it'll give me the time I need to terminate. The last thing I wanted to touch on that you might have noticed is I did not set any limits on any of these pods inside my application. I typically don't, but I will give you some advice if you are really insistent upon it. The worst thing you can do with an Akka.NET application is set the CPU burst limit way too low on it, because as soon as you have a big rebalancing act, or let's say a big surge in traffic on top of your application, which a lot of Akka.NET apps tend to be pretty bursty, you will immediately start nuking your own software from orbit when you do that. So I would recommend not setting a CPU limit at all. Let the application enjoy its really high bursts, and gradually the traffic will settle down. That is not a thing I would be trying to set a really hard and fast policy on. This is a stateful application. It should basically experience very brief blips in CPU utilization. The worst thing you could do for your software is have Kubernetes start shutting pods down when they're starting to actually activate actors and getting ready to do a whole bunch of stateful work. Don't do that. I would encourage you to not set CPU limits, but if you are really insistent upon it, they should be pretty generous. Now, the flip side of that is memory limits. Memory limits are actually quite useful for a stateful application like Akka.NET for one big reason, which is that in the event that you have a memory leak, these are stateful applications after all, so they're going to be more susceptible to that, potentially through a bug in the framework or your own application code. Or if you have something like let's say a hotspot forming inside your application where one node is getting a disproportionately large amount of work and it needs to be redistributed somehow. Having a memory limit can actually be a very useful way of enforcing some of that behind the scenes, which is that in the event that your pod begins consuming an excessive amount of memory, having it get restarted and basically crashed and restarted actually could be a healthy thing for the system. Again, I would not set ridiculously teeny tiny memory limits. I'd make sure each of your application instances has at least several gigabytes of data to work with. Actors are quite small. They don't use many resources by default. But if you're running a lot of them on each one of your instances, you're going to need to be equipped to do that. The last thing I wanted to touch on is that you don't see us using a horizontal pod autoscaler in this sample because it's quite simple. But generally, the metric you probably want to queue off of for horizontal pod scaling is going to be either a sustainably high CPU utilization number or a high memory number. Either one of those thresholds would be a good candidate for using an HBA to kind of scale your system horizontally. Akka.Cluster knows how to adjust to that pretty well. You don't need to do anything special with Akka.Cluster. Simply having Akka.Management to discover new pods and having Akka.Cluster itself is all you need to take advantage of the HBA, as long as the HBA can basically record the correct metrics out of those pods, which the CPU and memory metrics are so universal that shouldn't be a problem. So thank you very much for your time today. Please leave us a comment if we missed anything out. We'll try to address it in a new video. Otherwise, thank you very much, and we'll catch you next time. Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included, so blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.